Now that more than 500 piles, which are the 16-inch by 16-inch by 40-foot long concrete pillars, have been driven into the ground to hold the foundation for the new Connecticut Science Center, pouring concrete pile caps and grade beams are the next steps in creating the new Science Center. Pile caps and grade beams are made by constructing forms with steel rebar skeletons running throughout the forms. Steel rebar gives concrete its strength to carry the load of the building. Alone, concrete has great compression strength, but not tensile strength. The purpose of rebar is to increase the concrete's tensile strength and to anchor the building's parts to each other, physically connecting the pile caps to the grade beams. While all that may sound complicated, we actually have an expert with us today to explain how those types of foundations are made. And that expert is Kevin Miller from Tilcon, Connecticut.
Great to be here today, Chris.
Thank you. So concrete has been around since 500 BC, and I know there's a lot of science that goes into it. Can you get us from quarry to job site with the science in particular?
I'd be glad to. So I think now's the time. Let's proceed to our New Britain quarry. Let's see where it all starts.
Sounds great.
Okay.
The quarry has been in operation since 1923. The primary stone found here is basalt trap rock, which is known for its strength and durability, an important factor when producing quality concrete. Blasting, which is done on a daily basis in most of our quarry locations, is the first step in obtaining the stone used in the production of concrete. Blasting is a process by which explosives are placed into pre-drilled holes and then are initiated by electric or non-electric detonators. Throughout our entire operations, safety is first and foremost. Therefore, our workers are highly trained professionals and always put safety first. From the blast site, the large pieces of rock are loaded into an off-road haul truck capable of carrying over 75 tons and transported to the main crusher. At the main crusher, the large pieces of rock are broken down into smaller pieces. These smaller pieces travel on a conveyor system to the secondary crusher. Here at the secondary crusher, the stone is further processed and then separated by size for various construction uses as previously mentioned, such as asphalt. An additional conveyor system carries stone directly to our concrete plant, where it is stored in bins by size, waiting to be used in the production of concrete. Let's enter the heartbeat of our operation, our central dispatch facility. Customers, much like the Connecticut Science Center, will place an order with a dispatcher for a specific mix of concrete to satisfy their building needs. Once an order is placed, the dispatcher will electronically send a ticket outlining the concrete ingredients to one of our 9 concrete plants according to job site location. Up to 100 different types of concrete mixes are kept in the computerized batch system and retrieved automatically per job request. Once the plant operator accepts the ticket, the batch system automatically dispenses the ingredients that make up the concrete. These ingredients are approximately 10 to 15% cement, 10% water, 60 to 75% aggregates, which is the sand and stone. Most people think that concrete and cement are interchangeable names. Really, they are different products meant for different purposes. Cement is to concrete, much like flour is to cake. Portland cement is the most important part of the concrete and made primarily from limestone, gypsum, silica, and iron ore, which are put through a process that chemically changes the ingredients and makes the mixture reactive when water is added. When the cement, water, trap rock, and sand are combined and the water comes in contact with the cement particles, a process known as hydration starts. This chemical reaction leads to the hardening of the concrete mixture. It is important to remember that the concrete has a workable lifespan of approximately 90 minutes. Preferably, the concrete should be delivered within a 45-minute time frame to allow for placement and other variables. These ingredients are mixed together in a large drum, part of our central mix plant, which will then be raised to transfer the concrete into one of our mixer trucks. While the mixer truck travels to the job site, the drum is constantly turning to keep the concrete ingredients mixed thoroughly and prevent separation. Right now we're pouring a 5,000 psi 3/4 inch aggregate, top size aggregate, and basically we're dealing with about little over 1,800 pounds of crushed stone. We're dealing with a little over 1,200 pounds of sand, a little over 700 pounds of cement, and each yard of concrete equates to about 4,000 pounds. So right now that truck that's coming in with 10 yards is basically holding 40,000 pounds of concrete. When the concrete arrives at the job site, there is an independent tester who will check the delivery ticket to make sure that the right product is on the job. This person will then conduct a series of tests to assure durability and proper performance of the concrete. Another point we would like to make is Tilcon's commitment to a clean environment. Once our concrete trucks return from a job site, they pull up to a washout station where any remaining concrete is dispensed. And then the sand and stone gets separated out to become a recycled aggregate product.
Thank you so much, Kevin. We really appreciate your time today. I think we've really learned that the chemistry that goes into creating the concrete depends on the physical requirements of the job.
It's been a pleasure, and we're really happy to work on this project here at the Connecticut Science Center. Thank you.
Once the nearly 150 pile caps and their grade beams have cured, then the slab foundation for the parking garage will be poured. Here are excellent websites to continue your research on the chemistry and physics of concrete and cement. Thank you to the following organizations and individuals for their help: